Today we are going to combine factoring and solving with graphing these polynomials. So, first thing we need to do is do a quick review of degree and leading coefficient because that's going to help us sketch the graphs. Remember, the degree is the largest exponent. And we really care whether it is an odd number or an even number. The leading coefficient is the number in front of the term with the largest exponent. And we really care whether it is positive or negative. We don't care what the number is, we just care if it's positive or negative. So over in this blank space, we're going to make a fancy little chart. We'll look at odd degree and even degree. In an odd degree polynomial, the two ends of the graph point in opposite directions. So the left side down, the right side up, or the left side up, the right side down. You might remember odd opposite. With an even degree, we said even same. So the ends either both point up or the ends both point down. I can make this into a fancy little table here. The right side of the graph is controlled by the leading coefficient. So when the right side points up, that means that we have a positive leading coefficient. When the right side points down, that means we have a negative leading coefficient. Do you kind of remember that from last semester? Okay. So there's two ways to approach these problems. I like to get it factored and solved first, and then go back and look at the degree and the leading coefficient. One other thing that you're really going to need to know today is that solutions, X-intercepts, and zeros, those three terms all mean the exact same thing. We use these three words interchangeably, but they all mean the X-intercepts, the solutions to the equation, the zeros of the function. All of those are where the graph crosses the x-axis. So it's going to ask us in number 6 to find the zeros of the functions. They're meaning find the x-intercepts, find the solutions. So if this said 0 equals, they want you to put the function equal to 0 and solve it. And we learned yesterday that you can take a polynomial like this that equals 0 and you can factor and solve. So what do these three terms have in common? How many x's? X to the 4th. That would leave us with x squared plus x minus 6. And we would keep factoring, looking for two numbers that multiply to give us negative 6 that add up to 1. Negative 2 and 3. So we have 0 equals x to the 4th, x minus 2, x plus 3. Okay. The yellow part will give us one of our solutions. The green part will give us our second solution. And the blue part will give us a third solution. What is the yellow solution?
0.
0. What is the green solution?
2.
And the blue? Okay. All right. So the x-intercepts are 0, 2, and -3. I'm going to put those in numerical order. So -3 first, then 0, then 2. When we actually put this on the graph, having them in numerical order is going to be helpful for us. Okay. Over on this graph, notice it's a very simple graph. There's no lines, hash marks, grids, anything. We are definitely sketching these polynomials. So I'm going to count over and put one x-intercept at -3, put an x-intercept at 0, and put one at 2. This alone would give you a lot of information about which graph was the correct graph. Because you could look at 4 different graphs and say, well, it has to cross the x-axis at -3, at 0, and at 2. Which of these graphs does that? But sometimes multiple graphs will do that, so we need a little bit more information. Let's go back to the original problem and look at the degree and the leading coefficient. The degree is the largest exponent, 6. Is 6 an odd number or an even number?
Even.
And even numbers, the ends go in the same direction. That fit better. The leading coefficient is the number in front of the term with the largest exponent. In this case, it is +1. We don't really care that it's 1, we just care that it's positive. That means that the right side points up. So over here, if you go to the x-intercept, the farthest on the right, that right end has to point up. So from that x-intercept, our graph is going to have to go upward. And all the way on the left side needs to go in the same direction. So from that x-intercept, our graph is also going to point up. You may now have enough information that you could pick the correct graph out of a choice of 4. But there's something kind of interesting about the x-intercepts. It's talked about right up here. It's called crossing points and turning points. A turning point is where the graph is going to go toward the x-axis, but when it hits the x-axis, it will turn and go back in the opposite direction. Some people call it bouncing. It's like your graph goes up and bounces off of the x-axis and heads back the other direction. A crossing point, you just cross the x-axis. It is a turning point if the solution comes from a term that has an even exponent. So you're looking at where the solutions come from. The solution x equals 0 comes from this term x to the 4th, and that has an even exponent. So that is going to be a turning point. What exponent do these two parentheses have on them? A 1. If there's no exponent shown, that means it's an exponent of 1. So the solution x equals 2 comes from this green term that has an odd exponent, so that is a crossing point. Same thing with -3. It's going to be a crossing point because it comes from a term that has an odd exponent. So in my little chart over here, -3 is a crossing point, so I put a C. 0 is a turning point. 2 is a crossing point. This will help us kind of fill in the gaps between what we already know. So at -3, we are going to cross through that x-intercept. Then we'll come up to this other x-intercept. Are we going to cross or are we going to turn? Turn. That means we're going to go up and just kind of bounce off of the x-intercept. Imagine that your graph is like a ball following a path. It crosses through -3, it comes up, it bounces off of 0, and then it's supposed to cross at 2. So that crossing and turning information tells us how we get from the left side of the graph to the right side of the graph. On your assignment today, it's going to give you a bunch of possible x-intercepts, and you'll basically have to click that -3 is an x-intercept, 0 is an x-intercept, and 2 is an x-intercept. You'll click those 3 solutions. Then there will be 4 graphs, and you'll have to pick the correct graph. So if you make a sketch on your paper, from that sketch you should be able to look at the 4 graphs and say, oh, that one is the correct graph. Okay, let's try this again. Oh, the one thing we didn't talk about was Y-intercepts. If you plugged 0 in, 0 to the 6th is 0, 0 to the 5th is 0, 0 to the 4th is 0, and then 0 times -6 is 0. So your x-intercept would be, your y-intercept would be 0. And notice we have this point where it crosses the y-axis at 0. The hint here is if you have a number added on to the end of the polynomial, that is going to be your y-intercept. So take a look at number 7. Is there a constant number added on to the end of this polynomial? No. That means our y-intercept is going to be 0. Take a look at number 8. See how there's a +9 at the end? Your y-intercept is going to be 9 for that one. All right, let's go back to 8. We need to factor. I don't like that negative in front, so I definitely want to try to factor out a negative. Can we divide all of those by 4?
Yes.
Yes. Can we divide all of them by some x's?
X2.
X squared. That will leave us with x squared minus 2x minus 15?
Yeah.
Yeah. Okay, pause the video. Try finishing factoring this one on your own. Your x-intercepts should be -3 is the smallest one, 0, and 5. 0 comes from this first term that has an exponent of 2. So 0 is going to be a turning point. Both -3 and 5 come from these parentheses that don't have an exponent, which means it's an exponent of 1. Those are both going to be crossing points. The degree is 4. 4 is an even number, so the ends are going to point in the same direction. The leading coefficient is -4. That means the right side will point down. So if I start to put this on the graph, we've got -3, 0, and 5. The right end is going to point down. The left end is also going to point down. And then in between them, we're going to cross at -3. We need to bounce at 0 and then cross at 5. Okay, we got this factored and solved and everything. The right side needs to point down. The left side needs to point in the opposite direction. And we haven't yet talked about crossing or turning points. Look at where these 3 solutions came from. All of them have exponents of 1, so they are all crossing points. So we are going to cross at -3, cross at -1, then we need to come up here and hit that y-intercept, and then come back down, oh crap. Come back down around and cross at our +3.